And you can also find some patterns like this, like old binary, old function didn't call free, in proper way. The old binary was calling the memfree directly without checking the reference count, and the patched one was calling the release method that is doing some kind of reference count check. So that the original one had that kind of problem. So you can use replace PTR or memfree as patterns here. But I believe it's until 11. So looks like we are running out of time here. So here another example is default user data thing. It's used for zero-day attack to Google. And if you look into that, it has 2 entries here. And this is a very important example, actually. So actually, the original code was calling variant change type EX with the same argument, and the source and destination was same. And actually, the call to variant change type EX will destroy the destination data. So it was destroying some argument that has been provided from the other method. So the fix was this is the original one, and this is the fix. And the fix was like using different variable here. So just using some local variable here, and they fixed it. And you can use a variant to change type EX as a kind of signatures here. And looks like there are one more exploit, one-day exploit here, because there was only one. Exploits out there, but we find that there were 2 methods fixed here. So why they fixed 2, even though there were only 1 exploit known? So it means that they fixed something silently. And here's something that I traced, and looks like if you read here, the original problem was from C persist user data class same method set attribute to method, and it's related to default user data behavior. But the fixed one had another class like a C persist data peer here. So I traced back where this class and method is used, and it's actually from the behavior of default user default save history here. It's on the bottom, the last line, save history, and default save snapshot. So looks like there are another vector to exploit same type of exploit. So here's the exploit that I wrote. It's just POC. It doesn't have any kind of heap space code here. So it's using default save history here. The original exploit was using default user data. So the vendors might have created a lot of signatures related to this default user data, but you still exploit same kind of vulnerability using this behavior. So actually, there are another one like a default save snapshot here. So maybe you can try to create exploit for this behavior. You can try that one. And here's something to think about. Actually, this is what I was talking about today. Could the MS provide the information fully in the first place? They could just write some more 1 page of report about that in the first place, but they just missed it for some reason. I don't know if it's intentional or something, but they have some program called MAPP that is very cool, but looks like they are missing information, for some reason, maybe by mistake or intentionally. So this makes MAPP very unreliable, and it makes some problems with security vendors because they need to binary diffing themselves again. So And here's another thing, like exploit writing and mini code coverage testing thing. So you might wonder that if you have something like Adobe Acrobat or something, then if you diff the points, and it will generate, like I said, like a 10 or 20 meaningful results. And how can you write some exploit about that? You might not have any idea because you don't know about the format of all the stream for like Adobe format. It's all proprietary. Then you might wonder how can we create exploit for that kind of stuff. So I have a little idea here I'm suggesting here. So this is the last part of the presentation. So you just need to do some kind of a code coverage test for some small parts of the binary, because you already have the diff point, like 20 or 30 points of functions, then you are very interested in. So you need to put breakpoints for that functions, like 20 or 30. So it's not full code coverage test. So it's very fast and effective. So I used some example from like a CoolType font DOS. I used POC from like ExploitDB, and it created. I reproduced the problem, and looks like it matched this one. The SI is number 7. This is the actual CoolType font DOS. So you can just pinpoint which function is matched to which CVE number, actually. But how about the others? This one has CVE number, but how about the others? They are just patched without any kind of record. So how can you like exploit these other functions? So maybe you can use static analysis, but it's not easy because it's using a lot of C++ code, and it's like a kind of hell to like analyze all of them. So you use dynamic analysis here. It's I call it mini code coverage test. As I said, and you just Google random PDF document from the like a web, like a few thousand or something, and you execute Adobe Acrobat Reader against them, and you put like a breakpoint for like the points that you are very interested in, like the diff point, like as I said from here, you have all the functions here, right? Like 1, 2, 3, 4, 5, 6, 7, 8. So you just put breakpoint for these 8 functions. Maybe you can use your debugger or immunity debugger or Pi debugger, anything you want. But I just used JIT with 0xCC technique. I just modified the binary with 0xCC. I just put 0xCC to any function that I was interested in, and I assigned my favorite debugger as a JIT debugger. So if that point is hit, then my JIT debugger will come up, and I can collect the thing that I'm interested in at that point. So it is very effective and fast. So after that, I could collect matching, like matching sample that is matching. Actually, I used the first example here, sub 0x or something, and I actually found the matching document that is hitting that point. But it's not like exploit. It's just some base template for your testing. So you just need to because PDF documents are compressed, you need to decompress it, and you just need to change the bits inside it, and you can test yourself to hit the conditions that is matching the crashing. So actually, there was just out of bounds access vulnerability, so not sure it's exploitable, but I found that using this method within few hours. So you can try the same thing, and it's very easy. Even though you don't know anything about CoolType font, you can use this method to find something very cool within few hours. So yeah, here's the last one, static taint analysis. I tried this one from a few months ago, but it's very, very hard because there are a lot of C++ issues. It's not traceable sometimes, and virtual functions, and it's very difficult. But I still created a tool called IDA Tracker. It will trace the variables automatically for you, but it's still in like alpha phase now. So I'm going to release it like within a few months, and I will talk about this later. And here's the conclusion. So binary dipping can benefit IPS vendors or like AV vendors or vulnerability assessment vendors a lot, because they can write some signatures that hasn't been like disclosed before. And also it can be very useful for like exploit writers too. And I propose a security implication score here, and looks like it's working very well. And dynamic and static analysis can be used for like a binary dipping process, and usually looks like dynamic analysis is very helpful. And this is the last one. Looks like we don't have any time here, so the good news is that I will be at the Blackhat Arsenal. This is the first time here, and this is tomorrow afternoon, and it's from 1:30 to 6, and Arsenal booth number 1, and the tool name is Darren Grimm. So you can come here, and you can ask any questions you have, and yeah, we can communicate, and you can share your knowledge. And if you have any questions about the cool type thing, I can like answer you anything with that. And thank you.